Recording now, this is lesson 5.6 on graphing algebraic relations or graphing linear relations. Before watching the recording, please make sure that you have a pencil, a proper straight edge or a ruler, and you could have some colored pens or pencils on hand as well. If you need to pause the recording to grab those items, please feel free to do so now. Otherwise, I'm going to continue. Also, you may want to pause the recording now just to make sure you have today's date jotted down at the top of the page. You should be working on graph paper because we are graphing today in today's lesson. Please copy out a column chart as I have here, and then set yourselves up for an XY coordinate grid just in the first quadrant for today. So again, if you need to pause the recording to do that, please go ahead and do so. Otherwise, I'm going to continue. So this is an extension of what you did in 5.4, but now we're going to take a t-table and we're going to be graphing it on an XY coordinate grid. So just to review, we've dealt with input before. So I'll jot down input here. And obviously the other side will be output. This time your input, let's just call that X for now. I'm not going to give you what the output algebraic expression is because I'd like you to come and figure that out. So input, let's go 1, 2, 3, 4, 5. And make sure you're jotting this down as well. If the input is 1, your output is 1. Input is 2, output is 6. Input is 3, output is 11. And then 16, and then 21. Okay, now, before continuing, pause the recording now before I go over what the algebraic expression is for the rule in this t-table. So just a reminder, what are you doing to the input values to get to the output values? I'm going to continue. So to review the process of that, you're going to look, I can tell that this is a two-step algebraic relation. I'm going to see what you have to do the input to get to the output. Judging by this, I can also tell that perhaps the first operation is multiplication because the input values are a lot smaller than the output values. Now, what are you going to multiply by? Well, I look and see the pattern amongst the output values. I can see that each increases by 5. So that means that my coefficient is probably going to be 5. X is the variable because we're multiplying the input by 5. And then if you multiply the input by 5, you figure out the difference. 1 times 5 equals 5. How do you get from 5 to 1? You subtract 4. If 2 times 5 is 10, how do you get from 10 to 6? You subtract 4. If 3 times 5 is 15, how do you get from 15 to 11? You subtract 4. So you know that the constant is going to be 4 and you're subtracting 4. So that's the algebraic expression. To put it in words, remember you did this in an earlier lesson, you're multiplying the input, which is X, by 5. Then you subtract 4. Okay, so we know that the output, going back to the title of the output here, the output value, also known as y, but also known as 5x minus 4. So just a reminder to your basic input is x and your output is y. So it's always x before y. Now, to set up the graph, you don't always have to do this, but I just want to remind you, and this is going back to Unit 1, when we did XY coordinate grids and the Cartesian plane, that you always graph using an ordered pair. Remember, ordered pairs are always listed x coordinate first before the y coordinate. So it's x before y. This is going to be the x coordinate and then the 5x minus 4 coordinate. So the first ordered pair we are going to have is going to be 1, 1. The second ordered pair you're going to have is 2, 6. So if you want to pause it and do the rest, and then check in afterwards, go ahead. 4, 16, and then 5, 21. So now in total, we have 5 ordered pairs we're going to graph here on the right. Okay, So once we've set up the XY coordinate grid, again, we're only dealing with the first quadrant. The first thing we need to do is label the horizontal and the vertical axis. Remember, it's always X is the horizontal, Y is the vertical. X is the horizontal, Y is the vertical. Now you could leave it like that, but because we're going to deal with the actual algebraic relation, I'm going to call Y 5x minus 4. Okay, remember Y is the output and X is your input, so it's X before Y. Remember to label it, so just, I can see that my input, I can go up by 1, and remember when you're graphing, you always label the line. You always label the line, not the space, because you try to use the grid as best as possible. Now I can see on my output values, my lowest output is 1 and my highest is 21. So I'm going to have to adjust the scale on my Y or my output values. So I think what I'll do is I'll go up by 6, 8, 10, 12. I'll go up by 2. So 2, 4. And again, notice my spacing is even going up the graph, and I'm not skipping any spaces, and I'm always labeling the lines. So go ahead and do that, and if you want to just pause the recording, feel free to do so. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So I can stop there because I know my top value is 21. Now, if you want to pause the recording again and go ahead and start plotting the points, remember you're looking at your X value first before the Y value. So it's X before Y, and then where they meet, you plot the point. So for example, here, my first ordered pair here is 1, 1. So I'm going to look for 1 here on the x-axis, and I'm going to look for 1 here on the y, which is between 0 and 2. I'm just going to mark that in blue here. So where they meet, actually, where they meet is going to be about here. So that's going to be 1, 1. Okay. The next point that I'm going to do is going to be 2, 6. So I look for 2 on the x-axis, and then I look for 6. Now you don't have to do the dotted lines here. I'm just doing this as a guide. And I plot it here. I know that's 2, 6. The next one I'm going to look at is 3, 11. And you can go ahead and just go ahead of me if you want to. So 3 on the x, and then 11 is going to be between 10 and 12 on the y. So it's going to be about here. 3, 11, and then the next one is 4, 16. I know it's 4 on the x. I'm looking at the x first, and then 16 on the y. I'm going to mark it here, so that's going to be 4, 16. And then finally, the last one is going to be 5, 21. I'm going to look for 5 on the x, and then I know 21 is going to be between 20 and 22, about here. So that's going to be 5, 21. Now, it's not a requirement to list the ordered pairs beside each of the points that you plot. I'm just doing that as a guide for you and to help you remember. Now, ideally, you want to use your straight edge and connect the dots. I do not have a straight edge in this program, so I'm just doing it carefully, but make sure you're using a proper straight edge. Now, you know you're correct in this case where you're graphing an algebraic relation where your lines fall into a straight line. So make sure you're doing it properly. Again, points to remember when graphing, you have to label your horizontal and your vertical axis, preferably x and y. You can call it input, output. In this case, I labeled it in terms of the algebraic relation. Make sure your scale is even. Make sure you're labeling the lines, not the spaces, on a graph sheet of paper, and that your scale is even as well. The last thing that you want to put on your graph is a title. So for this, I'm going to call it, I'm actually going to use the algebraic relation, which is the best and most specific way to name it. So it's 5n minus 4. Oh, not 5n, sorry. It should be 5x minus 4 against or versus x. And then you can use a straight edge to underline that title there. Okay, so From the beginning again, you started off with an input-output table. You'd established what the algebraic expression is, relating the input to the output values. We know that corresponds to the x and y ordered pairs. So remember, whenever you're listing ordered pairs, it's always the input or x before y. And then when you set up your graph, make sure that you label your x-axis or horizontal axis and your y-axis. Make sure you set up your scale properly with even spaces and plot your points. Finally, end with a title, and then you know you're correct if your points fall in a straight line because you're graphing what's called a linear or algebraic relation.